Good afternoon, everyone. I think we'll get started because we want to make sure to end on time, and I'm hoping there's some really great discussion this afternoon. Thank you for joining us for today's webinar, What's Next in NanoEHS, the Young Professional's Perspective. I'm Quinn Spadola, the Deputy Director of the National Nanotechnology Coordination Office, and I have the pleasure of moderating the webinar today. NanoEHS is not my area of expertise, so I think I get to be a stand-in for members of the audience who might ask silly questions. There's no bad questions, just the ones that non-experts would ask. The NanoEHS webinar series is an important platform for agencies participating in the National Nanotechnology Initiative to share information on federal nanotechnology, environmental health and safety, or NanoEHS, research progress and findings. Before I introduce today's panel, I want to share some of the background on this year's theme and how it fits with the priority NanoEHS activities coordinated by the NNI, or the National Nanotechnology Initiative. First, I want to note that the U.S. government's commitment to understanding the potential health and the environmental implications of nanotechnology has been a central part of the nanotechnology research framework since the early days of the NNI. The creation of the Interagency Nanotechnology Environmental and Health Implications, or NEHI working group under the NNI was a pivotal in charting a path forward to address key NanoEHS research questions. NEHI is currently spearheading the review of the NNI's current EHS research strategy, which was published in 2011. The refreshed strategy will describe the substantial progress since the strategy was published and point to needs, questions, and directions to meet the NNI's goal of the responsible development of nanotechnology. The NNI public webinars have been an important avenue for connecting diverse NanoEHS experts with the public. The 2021-2022 series shared perspectives on the progress that has been made in understanding EHS implications of engineered nanomaterials, and the NNI's role in answering research questions and each of the NanoEHS research strategies' core areas. As the NNI approaches the 20th anniversary of the initiative's authorization, the 2023 series will be focusing on hearing from experts from academia, industry, and the U.S. government on future directions. To help us jumpstart the 2023 conversations, we are excited to bring together 3 scientists who are leading the next phase of NanoEHS research. These researchers have been trained and supported by the NanoEHS Foundation that's been built over the past 20 years. Our speakers have been nurtured by this infrastructure and are addressing the key questions that are emerging in the NanoEHS space. Today, we're going to hear from Marissa Giro, who is a postdoctoral researcher at EPA, Yemi Adele, who is an assistant professor at the University of California at Irvine, and Joanna Sipe, a postdoctoral researcher at Duke University. Marissa's research focuses on how emerging contaminants of concern, such as nanoplastics, affect the marine ecosystems. Yemi's research areas include environmental nanotechnology and biochemistry, and he's interested in improving water sustainability by investigating the release, fate, and effects of emerging pollutants in the environment. And Joanna, her postdoctoral research associate work is on the fate and degradation of nanoscale additives in plastics, as well as in nanoinformatics. We've asked them to further introduce themselves in their opening remarks, as well as talk a little about what motivated them towards their research topics and what key development or what questions would they like to see answered or settled. And finally, before I turn it over to Marissa, I hope that to let you know, we hope that you join us for other webinars in this series, and that there's more information about our NNI public webinars that can be found on nano.gov. And now I'm going to let each of the speakers do their intros and their opening responses before we move on to questions. So over to you, Marissa.
Hi, everyone. Let me just share my screen. And can you all see this version? Oh wait, I need to turn off closed captioning. That would help. Perfect. Okay. I'm Marissa Giroux. I'm an ORISE postdoctoral research fellow at the U.S. Environmental Protection Agency's Atlantic Coastal Environmental Sciences Division, which is a total mouthful, but we are a small research and development facility in Narragansett, Rhode Island. I'm an ecotoxicologist by training. My bachelor's is in marine science and my PhD is in environmental toxicology. So I did not start off thinking that I would do any sort of nanotechnology or nanomaterial research, but I just want to tell you a little bit about my journey to this point. In my PhD work, I mostly spent my time researching the effects of endocrine disrupting pesticides to several species of salmon and trout. And so I have a lot of experience on the mechanistic molecular side of toxicology. And so understanding or working towards understanding the effects of pesticides to individual organisms, to individual fish, really started to get me thinking about the effects to whole marine communities and looking at contaminants of emerging concern and finding ways to rapidly and comprehensively assess the effects of these contaminants of emerging concern, which I would put nanomaterials under that umbrella. And so most of my work during my postdoc at the EPA has centered around developing environmental RNA metabarcoding tools. And so what I do is I go out into local estuary and I can collect mesocosms, which are pictured here. I bring them back into the lab. And so we have this representative community of invertebrates and organisms from the field, which we then can expose to set concentrations of nanomaterials. And what I've spent the majority of my postdoc doing is I've been looking at nanoplastics and nanocopper boat bottom paint and how those affect these marine communities. So the tools that I use, environmental DNA and environmental RNA, simply that's environmental, or that's DNA and RNA that comes from environmental samples, in this case, marine sediment. And I can take that marine sediment, extract out the RNA and DNA, sequence a specific gene, and then I can take those sequences, match them to a database, and get a pretty comprehensive overview of the types of unique organisms in the mesocosms in my little mesocosm communities. And so this is a really nice, rapid, and comprehensive technique to get a better overview of types of organisms that have traditionally been left out of biomonitoring studies and that aren't typically used in toxicity assays, so that we can effectively understand the sensitivities of different types of organisms that are actually out in the environment. We can also look and see how different types of organisms are interacting with each other. So we can look at microbes and neofauna and macrofauna, and we can look at these different trophic levels to see if there's an effect of the toxicant or the nanomaterial, how there may be an indirect impact to these different trophic levels. I just want to give you a very quick idea of the type of results we see with this eRNA metabarcoding data. So this is a principal coordinate analysis plot where each point on the plot represents an individual mesocosm, so the community of organisms in an individual mesocosm, and it's showing the differences in community structure and composition of these marine invertebrates in these mesocosms. So this is from an experiment where I used 900 nanometer polystyrene spheres. And so we use 0.1 milligram per kilogram concentrations all the way up to 100 milligram per kilogram concentrations in sediment. And so we have these light yellow points are the lab controls, then the lighter orange are the lower nanoplastic treatments, all the way up to this dark red or the highest nanoplastic concentrations. And what we see here is that there's a shift in community structure. So a shift in the types of organisms and community composition from our controls to this highest nanoplastic treatment. So we're seeing this dose response at the community level due to polystyrene plastic exposure, at least in these invertebrate communities. So this is just giving an example of how we can effectively look at community level impacts of nanomaterials, in this case, an incidental nanoplastic particle. Something else that I've been spending, or I spent a lot of time on in collaboration with Yemi's group, we recently wrote a review to assess the environmental effects of quantum dots, both metal-based and carbon-based quantum dots. And through this, we identified several data gaps to move forward and suggest future research areas for quantum dot research related to environmental exposures and environmental health. And so in writing this review and identifying these data gaps, I started thinking about how to move forward with my research and questions that I would like to see answered, which was one of the things that the organizers asked us to think about. So 2 questions came to mind to help move my research forward from an ecotox point of view. The first is the standardization of units for doses and concentrations used in lab studies. In writing this quantum dot review, the reported concentrations, units for the concentrations and doses were all over the place depending on where the authors were from, the type of nanomaterial, and it made it very difficult to compare toxicity between studies using the same types of quantum dots. And so I think the standardization of units would really help to make the studies more comparable, and or even reporting multiple units, so particles per milliliter and milligrams per liter, things like that. It would really help to standardize and be able to compare between toxicity studies. And the second thing that came to mind was advancing the detection of nanoparticles in the environment to more accurately guide dosing in lab studies. As somebody who does lab studies, I really want to make sure that my concentrations reflect the actual concentrations that we might find in the environment, so that we can get a real sense of the types of effects at the concentrations found in the environment. And there's been a lot of advances for detecting engineered nanoparticles in the environment. But with my recent work in nanoplastics, there's a lot to be done to really understand the concentrations of nanoplastics in the environment and get to get a realistic idea of what concentrations of nanoplastics we're seeing in aqueous environments and in sediment. So those are 2 things that I would really like to see to move the ecotox field forward when looking at nanomaterials.
Great, thank you. And you already started us off with 2 needs. That's fantastic. Next, we're going to be hearing from Yemi.
So good morning, everyone. My full name is Adeyemi Adeleye, but I go by Yemi as Queen introduced me. So just to introduce myself a little bit more, you probably heard my accent already, so let me make it clear. I was made in Lagos in Nigeria. Nigeria is highlighted on the map on the screen. It's on the western side of Africa. Pretty beautiful on the southern side where I came from. It's right by the Atlantic Ocean. And one thing that is really unique to us is the fact that we depend quite a lot on petroleum. It's the biggest natural resource we have. And if you look at the figure on the right, you see that about 84% of what Nigeria exports is based on petroleum, either as crude oil or as the gas. Essentially, that means we cannot survive without crude oil. And what does oil mean for Nigeria? It means a lot of money. People can afford to live. The country can pay its bills, but it also yields problems, particularly environmental degradation. So when I finished my undergrad, I wanted to go back to school for graduate education to gain knowledge on how to address the problem of environmental degradation resulting from petroleum. But it didn't take too long for me to figure out that, yeah, it's not like we don't really know how to take care of the problem. It's the political will, it's policy, and it's just priority. So when I moved to the US for graduate education, I ended up at UC Santa Barbara, where I really found out that there is a new technology that we think can benefit society, but we don't fully understand the implication of using that technology. And that was how I was introduced to nanotechnology through the UCCIN, one of the big centers funded jointly by the EPA and the NSF in the early 2000s, I think. So I started by working with Trish Holding at the Brain School at UC Santa Barbara, specifically looking at the impact of nanomaterials on microbial processes during wastewater treatment. And then I continued as a PhD student with Arturo Keller, looking at the fate of nanoparticles. So I essentially went from bio with Trish to chemistry with Arturo, which is one of the fantastic opportunities you get at the big centers. There's a lot of expertise that just come together and you learn, and you can also develop your skills that way. So do I regret not doing oil? Not really, because if I replace oil with nano can improve society, it can generate income, it can improve life outcomes, but at the same time, it can also lead to degradation, which is where the NanoEHS comes in to make sure we can still derive the benefit without really degrading the environment. Once I left Santa Barbara, actually, I should say, once I was kicked out of Santa Barbara, it's such a hard place to depart from. So after 7 years, I was kicked away, and I ended up at Rhode Island, the lab where Marisa is right now. We actually I worked with the same mentors that she's working with right now. And from there, I moved back to California, where I currently work as an assistant professor at UC Irvine. So what do I do now? I actually have sort of transitioned to looking at application of nanotechnology, but still bearing in mind the fact that the materials could have possible negative impacts, and that needs to be quantified, particularly at the same time we are applying them. So my group is interested in using nanomaterials to remediate heavy metal contaminated soil. There is a lot of study on groundwater remediation with nanomaterials, but not as much with soil. And we simultaneously quantify the toxicity of the materials. So you can see a picture up there. This is a soil system that we work in, and in the middle, you might notice there's an earthworm in there. So what we do is we apply the nanomaterials for remediation and also have some organisms present at the same time. So we are measuring the success of remediation and at the same time measuring the potential impact of the remediation process. And that work has transitioned to looking at how we can decrease metal uptake in agricultural soils, because that's an issue right now. And I will talk a bit more about that in my next slide. And lastly, we're trying to use nanomaterials to degrade emerging contaminants. So my research still cycles around nanotechnology, but I'm looking at using them for my training as somebody, my training as someone that studies the effects of nanomaterials and their environmental effect is essentially impacting the way we set up our studies to, as much as possible, simultaneously look at the benefit and the risk. So here's the motivation for the plant-related study. We started looking at using nano for remediation in soil in 2019. Later that year, a report came out from an NGO saying, hey, we bought 168 baby foods from grocery stores around the US, and 93% of them had lead at levels that were higher than what the FDA recommends. 75 had cadmium and arsenic at levels that were higher than the FDA recommended, and about 30% or so for mercury. And this was in baby food, so it caused a lot of uproar as expected. And in 2021, our study that we started in 2019 was published, showing that nanoparticle can actually immobilize arsenic in soil. And the level of success depends on the dose as expected. Later that year, the FDA started the Closer to Zero initiative, at least the action plan aspect of Closer to Zero. And one of the action plans of Closer to Zero is working with the USDA to develop techniques to decrease uptake of heavy metals by food crops, which is the major way those metals get into baby foods. So our lab since 2022, last year, started to look at the efficacy of the materials we found were effective in 2001 in bare soil. Now we're asking the question of whether those materials can be effective when plants are present in the soil, because plants do change the physics, the chemistry, the biology of the soil. So the question we're asking is, can the nanoparticles still be effective without negatively impacting the plants? So my last slide is about one key research question I would like to see answer, or a key development I would like to see. And for me, I would say it is community-involved NanoEHS research. And I will give an example of what that means. If I get some money from, say, the US EPA to determine the environmental impact of nanotechnology used in TV screen, what I will probably do will be to go to Amazon, buy a bunch of TVs, different sizes, different manufacturers, different types of nanomaterials probably, and start to determine the probability that those nanomaterials would leach out. So that's one way to do it. But I think a better way to do it will be to look for people who already have the TV and have used those TVs for 1, 2, 5, 10, 20 years. Those TVs that have been used at home for a pretty long time have been exposed to things that the ones I buy from Amazon haven't been exposed to. And they will better represent the end of life of TVs than the brand new TVs that I would buy from Amazon. So I think that is something that we haven't been doing, and it's something that I would like to see the community do more, which is to use materials, devices, products that really represent the life cycle of those products, because that's how we can truly determine or perform the risk assessment of those products. Thank you, and looking forward to speaking again. So.
Thank you. It sounds like we need a citizen science style NanoEHS effort to look at the life cycle of some of these products. Excellent. Thank you. And the last person we're going to hear from for an introduction is Joanna.
Maybe I should unmute myself. So I would like to introduce myself a little bit. Thank you for inviting me to be a panelist for this event. So I didn't start as an engineer. I actually started as a music major. And the reason I went into engineering and nanotechnology is because I wanted to help people. And the reason I wanted to help people is my grandfather, who I was very close to, passed away from air pollution over in Fresno. And so I started in air pollution research with Dr. Pierre Herkes in Arizona State. So I transitioned into a Bachelor of Science in Chemical Engineering because they didn't have environmental engineering at the time there. And then from that research in particulate studies, I was able to work with Dr. Paul Westerhoff and LC Nano, which was an EPA-funded nanotechnology life cycle assessment, and I worked on nanoparticle textiles in undergrad. And that's a picture of me at my first poster session I ever did, and at the SNOW conference. And I think that just integrated how much I wanted to do research in the future. And so from there, I met some students from Mark Wisner's lab, and I ended up doing my PhD at Duke University in SAINT, so the Center for Environmental Implications and Nanotechnologies, and was able to work with a great group of people. That's the lab group we have on the right, and then also a lot of government networks that are through the NCO, so from NIST and U.S. Army Corps of Engineers, and then CPSC. And how did I get into my research topic that I'm in now? Right now I work in microplastics, and I think there's a lot of transferability that I learned from nano that I applied when I went into microplastics when I got the GRFP. And that's because the sizes are they can go down in nanoplastics, the shapes and the compositions. We have coatings like we had in like silver nanoparticle coatings, right? And that was it was a good transition for me to apply what I learned in nano. And then I used skills that I learned from the LC network for the life cycle network and applied this to the life cycle of microplastics. So when I worked in my PhD, my dissertation, I worked on the breakdown of plastics into micro and nanoplastics. And that's from plastics themselves, from nanomaterial enhanced plastics, to the toxicology, as well as to weathering. And here is a little bit more of details of like publications that I have come from these, but I just wanted to talk about how all 4 areas were very broad. They were connecting to interdisciplinary. And so the first area was very collectively integrated with materials and mechanical engineering. The second part with nanoinformatics through the NIC and work with Jalicia Amos here at Duke. And then thirdly, toxicity of nanomaterials and composites here with work at the Nicholas School with Melissa Chernick. And then weathering, which had to do a lot of work with the bio people over in the greenhouses that we used. And I think nano research helped me be an effective communicator with all of these areas of interdisciplinary research, which I think is something we should look at in the future, is how we're best been trained to be the communicators and connectors and bridging what we learned in nano to other disciplines of research. And I just wanted to talk a little bit about one of the standards that we developed here. So I think there's a huge need for standardization in new emerging technologies. So here we developed through a NanoFeet grant, work with CPSC and the U.S. Army Corps of Engineers and NIST, a standardized protocol for breakdown of microplastics through a power scaled input. And you can reach out to me or look at our NIST special publication to learn more about that. And we applied this to 3D printed materials, which is also an emerging new contaminant, and the release of microplastics as well as nanomaterials from these new nanocomposites that were being used. And then I just wanted to talk a little bit about the what was new from the mixture that we also need to look into mixtures is that when we go to toxicity of composites, when you enhance microplastics and the polymer matrix enhances toxicity that was not seen when we look at pristine nanomaterials. And I think that's something that we have to look forward in the future, that it's not pristine nanomaterials anymore, that we can learn from that stuff, but I think we need to learn how we apply what we learned from pristine nanomaterials to the new mixtures, because those are finding higher toxicity levels, at least what was found in our study. And new overarching areas of interest for me is fate of microplastics, the applicability to new products, and safer by design materials. And the big questions I also think that we should apply is the transferability that from what we learned from nano, and then the new connections like Yemi kind of talked about. And this is done right now. We're having a network of networks grant that I'm part of here at Duke, and it's connecting old groups of nanomaterials to apply what we learned, as well as create new areas of research. Thank you.
Thank you all so much for your introductions. Really great way to start off this conversation of our young investigators. And I just wanted to remind the audience as well, feel free to put questions in the Q&A and we'll address those as well. But as moderator, I'm going to ask the first question. And this was touched on by Yemi and Joanna in particular, but I really wanted to give you all an opportunity to talk about this a little more, is because we are both looking back at the previous research strategy and now looking forward, and you've had that benefit I mentioned in the beginning of coming up through this NanoEHS infrastructure. I would love to hear more about how some of you have touched on it, but how you've benefited from this existing infrastructure, these large centers like SAINT, this ability to talk to so many different researchers across disciplines, this ability to hone your communication skills, but more importantly, thinking in the future and moving forward, now that you are postdocs or young faculty, what more do you need? What infrastructure, what new support is out there that you feel that we need to be looking at in order to support the next generation of NanoEHS researchers? So I'll let you unmute your mics and have this conversation amongst yourselves respond to each other, but I'd love to hear your thoughts on this. And don't be shy, just who's going to unmute first?
Yeah, so I can start, excuse me. So like I said, I did enjoy the fact that I had access to people with all sorts of different skills and trying to answer the same question, which is what's the environmental implication of nanotechnology? So I don't think I ever did a study that just focused narrowly on the fate of nanomaterials. We had people that could essentially tailor any type of nanoparticles, any type of size and shape and chemistry that you would like. So it was great to have all those people in the room. And of course, till today, I still keep in touch with a lot of them. And that way also, there is multiple ways we look at research in my lab right now. We are chemists, but we also try to look at other aspects of nanomaterials while we're understanding the chemistry as well. In terms of what I would like to see, I personally miss the UCCIN days. I definitely miss it. And I think compared to when I was being trained, we do have fewer center type of structures looking at NanoEHS. I don't know for sure if they need to be back, but from what Joanna said, it looks like there's also center or networks of networks, which is also excellent for sure.
Mm-hmm.
But I'm also thinking there are people who didn't come through these centers. They may have been trained in other countries, other continents, and they may not even know about those infrastructure. And I'm wondering if we have enough word out about those infrastructures and what people can access through those infrastructures. Like I know there are some funded centers where you can go characterize your materials for free, but you may not know that if you didn't train in the US. So I would like to see more information out there that, those infrastructures are available. It could be through social media, which a lot of us as young researchers use a lot. That's one thing I would like to see more of.
Joanna, Marissa, do you have anything to add?
I agree with what Yemi was saying. I think it's more of an openness to reach out to people in the first try, if that makes sense. To introduce people to new people, it's hard to reach out and cold call someone and say, I read your paper and I really want to talk to you. I think having connections that the NNCO can help facilitate would make it better for younger researchers to have the resources they need. And I think leading to resources is having more open access opportunities. I think it's leading, a lot of the research that's open access is more accessible for all. And a lot of those journals have fees that are unreasonable to have as open access. So I think is developing something that's through maybe the NNCO that's an open access data source for all researchers on what we learn from nano and applying nano and new emerging risks to address would be useful.
Just to add on, I think that my training was a little bit different than Joanna's and Yemi's, and that I kind of came to this field as a postdoc and kind of an indirect path. So I wasn't really trained in any of the national centers, but I did benefit from that network. I think that when I started to think about, okay, what research gaps can the techniques and methods that I'm developing, like how can I use that in this nanotechnology field? I think that those networks were really helpful in kind of looking at the website about webinars and like just kind of all of that condensed information was there for me. But I would agree with Yemi that I think broadening kind of the marketing for this group would be really helpful for catching the attention of emerging researchers and newer researchers that are in this field but really don't know that we exist. So I think that that would be helpful for bringing more folks together.
Thank you. I'm taking notes, and it sounds like awareness, which comes back so many times, and creating these networking opportunities, really two big keys and things that this office at least tries to address. And I'm going to pull from one of the Q&A. We've got a lot in the Q&A already, and I also have a list here, but I wanted to get one in particular because I think it ties back to awareness and also creating these networks, and to the refresh of the research strategy that I mentioned in the introduction. And this was a question about how nanotechnology includes so many different scientific disciplines, and you work from an EHS framework, as well as there's legal, regulatory, policy, and so many other experts that really need to be at the table to make this overarching policy, or excuse me, research strategy, for example, and to approach some of these questions that you're asking. Who do you think are these communities that we really need to make sure are at the table? And if they're ones that you think are missing, how would you suggest we get them there? That's for me, awareness, right? And we are trying to reach as broadly as we can and be very intentional. But I would love to hear your thoughts on who we're missing and how we can make them aware. And please don't say just social media. That's a hard one. So, and why don't, if you're ready, Marissa, since Yemi went first, I'm gonna put you on the spot this time.
Oh, who is missing from this group? I think, yes, definitely from the regulatory side of things. This is something as an ecotoxicologist that goes beyond nanomaterials, really looking at beyond standard toxicity assays. And I think this is developing rapid high throughput toxicity assays was on the last like NanoEHS guidelines. But I think that there's a lot more to be done because nanoparticles don't often act like classic contaminants. And so working on integrating new toxicity assays and investigating sublethal impacts would be important considerations for the regulatory management side of things. So I think bringing those folks to the table and kind of seeing like, okay, what assays are we doing that effectively assess the toxicity that nanoparticles exhibit in the concentrations that we may be seeing them in the environment? How can we integrate that into risk assessment and management, and going beyond traditional toxicity assessment, toxicity assays. So for me, I would like to see that happen.
Great. Joanna, do you have anything to add or any thoughts on who we're missing?
No, I agree with Marissa. I think there's a lot of policy, especially in the emerging for microplastics research, that there's a lot of policy that needs to be integrated, especially for water contamination, because the United States has the dirtiest water for microplastics in the world. And I think that needs to be addressed, and that's something the NNCO can bring up, because we have dealt with clean water with nano, and so clean water with nanoplastics is the emerging issue of policy that I think we need to address.
Yeah, if I could just tag along, I would say that perhaps we do need to integrate the public a bit more in our research, kind of like what I ended my introduction with. And apart from citizen science style of research, I'm also thinking that in the scientific world, there is a lot we find and publish every single day, but there's almost no mechanism for those findings to get to the public. In one way, they are published in journals that you probably can't access if you don't pay hundreds of dollars or even $10. I, as a public member, probably wouldn't pay $10 just to read an article. No matter how curious I am, even as a researcher, I won't pay it. If I can't access it for free, I'll be fine on accessing it. So do we really publish stuff just for our consumption is kind of the question I'm asking, or do we publish things so that the public can be informed? Because I feel that a lot of people still think of nano as something they don't want to deal with, something they don't want to touch. And it could also just be because of lack of education. And in the last 20, 30 years, there has been so much done on EHS. And I'm just asking if those translate to ways that the public can access. So the other way I'm thinking about it is, a few times I've seen some website pick up a publication and try to write something about it. And I don't know if those are plain enough in terms of the language they are reading for the public to be able to consume. So I would say that engaging the public could also be finding ways to rewrite, maybe summarize a new finding in a plain language that everyday person can pick up and understand what we say we found. And I think that would be useful too. So in a way, I think of that as also bringing the public to the table. So at least we can hear that they are concerned. They're also informed about what we are finding regarding NanoEHS. So they have scientific information to know what's going on, essentially.
Great. All of these were really excellent comments. And I just wanted to point out that with the administration, the Office of Science and Technology Policy, they are pushing the year of open science, and there is a policy where they're really pushing for open access to provide, so to Yemi's point, you don't have to pay in order to get this information. So that's certainly something that is being addressed. And I think particularly in this field and these topics, so powerful that the general public or interested citizens can get access to that. But then speaking to your last point, the plain language aspect of it, how are they interpreting that? What tools do we have available, and who's communicating that information even once they have access to it? That's really great. Corollary to that needs to be thought about, how we share that information. I want to switch gears just a little bit, and we've heard a lot about micro and nanoplastics. There was reference to 3D printing and also air pollution at the start of Joanna, what motivated her to get involved in this. The current NanoEHS research strategy is focused on engineered nanomaterials and an understanding of them in the pristine state. And I'm glad there were points made about needing to look at them in mixtures and matrices and things. But in your mind, how do you see we should draw that line or kind of expand the scope to capture things like nanoplastics and 3D printing without taking over or trying to capture a research strategy for all incidental nanomaterials? There's so much work out there in air pollution, of course, and I'm not sure that we have the ability to capture all of that. So how do you scope your work? How do you see incidental nanoparticles, for example, versus air pollution? And what are your thoughts about scoping it so we're not just engineered, but we're not all incidental as well? So Joanna, would you like to go first?
Yeah, that's a great point. I think we have to say that we can't reinvent the wheel. Like, I think a lot of the stuff that we learned in nano, we can apply to incidental nanomaterials and also like nanomaterials that are engineered. It's just, they have caveats, right? And I think what you're saying also is like, do we ever draw a line in what is a nanomaterial and what we use for nanomaterials and not? Is that correct? That's what you're asking.
Well, I guess, do we draw a line between how we should scope our research strategy, what nanomaterials we should be of concern, I guess, for something like this? How do we? There's only so much time and effort that we can put towards this, of course. So what are the incidental nanomaterials? If we want to broaden our scope, how would you include some but not all? Where would your thinking go with that?
Personally, I think it would go to what I like to do, what the public is interested in. So when I was scoping materials of interest, I know that news articles usually get it out of scholarly articles, like Yemi was saying, like that they're translated to, but we also know that they like to fixate on a line and maybe scare people into not drinking water anymore because water has all these contaminants, for example. So I think we need to also keep in mind, at least I like to keep in mind and ground myself, is why I started becoming an engineer is to help people. So what do we think is going to help people the most right now and help people in our communities, but not only in our communities, but in underrepresented communities that are not listened to, are not thought of initially. So I think that's where we should start, is looking at places like colonias, or looking at places that primarily Black instituted neighborhoods, and make sure that their needs are being met. And then coming from into our communities, are our water treatment needs being met with, like, for example, PFAS here in North Carolina and Durham. Like, so I think that's where we should start. And I don't know if that answers your question.
No, I think it certainly does. Yemi, do you have anything to add?
Yeah, I can piggyback on what Joanna was saying. So I'll just take a step back to when I was a PhD student, and it would take me maybe 1 or 2 years to really study the transformation of one nanomaterial. And I would have done that for perhaps one material with different sizes. And within that time, perhaps 10 other versions of that nanomaterial could be created with different shape, different morphology, and functionalization. So at a point, we came to realize that even for engineered nanomaterials, it is impossible to really study all of them. It's just impossible. It's not practical. And that's kind of the way I would like to see incidental materials or incidental nanomaterials. So over time, what started to happen with the engineered is we thought maybe it's better to just understand their properties, their physical chemical properties. And when we understand those properties, we can make predictions as to how they will behave in the environment, as to how they might impact organisms and humans. And I feel like perhaps the way I would think about it is, rather than draw the line, definitely what Joanna said is important. We need to prioritize what's mostly used right now in terms of volume, in terms of products that people are exposed to. But at the end of the day, we still cannot study all of them. So what I would say is, for incidental materials, I don't think the goal of studying a number of all of them is even possible. So perhaps I would say we can prioritize really understanding the materials chemistry and their physical properties. And based on that, we can use QSAR models. So that's quantitative structure activity relationship models to make predictions as to what their environmental fate and toxicity might be.
Marissa, do you have anything to add?
Yeah, kind of going off of what Yemi's saying, coming from a toxicity, ecotox viewpoint, I think that there's a lot of similarities in the mode of action for some nanomaterials, like as a particle. And I think mixtures of different types of nanomaterials, even different sizes of nanomaterials, like just mixtures in general, have been very understudied. And the reality is, organisms in the environment and presumably humans are going to be exposed to mixtures. And so we really just don't know the synergistic or additive effects of these nanomaterials to really understand risk. If the goal is to assess risk, like if we're putting these nanomaterials out into consumer products, we're using them in direct environmental applications, and also experiencing exposure to nanoplastics, which are increasing in concentration because there's so many larger pieces of plastic that are then breaking down into smaller pieces of plastic. So the concentrations of nanoplastics are increasing. Like, if the goal is to assess risk, finding those common mechanisms and maybe predicting the effects based off of the different volumes, like Yemi's saying, the different volumes of nanomaterials that are ending up in the environment, whether that's incidental or engineered. So I think we can kind of find those common mechanisms of action and work from there, rather than identifying what's unique about each one, because then, like Yemi said, there's just so many and they're constantly changing. So what's similar? How can we proceed from there and kind of inform those next steps? But that approach may also, that would include incidental nanomaterials, which we are coming into contact with, and so are organisms in the environment.
Thank you. And that sort of segues us to a question from the audience that I'm going to try to paraphrase and ask. And I think this is maybe this falls into the because I'm not an expert area I wanted to ask. And the question has to do with, as you're studying these nanomaterials and the risk to the environment and to human health and assessing their risks, the question is about how are you protecting yourselves from any unknown risks as you're making these studies. And then they actually pull in more connection to medical resources in the medical. And I think you mentioned regulatory, and someone talked about working with the FDA, I believe at one point earlier today. So how do you protect yourselves, and how do you connect with, I guess, medical research in the medical community and the exposure to human health in that way? Maybe that's a silly question. Like I said, I'm not an expert. So.
I don't think I have all the answers to that question, but I just wanted to share my experience. The very first work I did on NanoEHS was my master's thesis, which essentially was to gather all the information we have out there on NanoEHS. And at the end of the day, the only thing we found that was comprehensive was NIOSH's guidance document. This was back in 2010, 2011. And then fragments of information on universities' websites, companies' websites. So I think the question of how to protect ourselves is been around for long, but I think also that over time we found ways that we can work with nanomaterials without unnecessarily exposing ourselves. So we have enclosures today that are specific to nanomaterials. We have PPEs that are specific to nanomaterials. And I think when I was at the EPA, I was made to do some comprehensive checkup every single year and when I left, I did double comprehensive checkup to make sure that I hadn't been overly exposed to nanomaterials. So I think there are materials, well, resources, I would say, out there now based on studies done in environmental labs as well as medical labs on personal protection.
I think it's overwhelming to think about all of the nanomaterials out there and try to protect yourself from all of them. From my understanding, the release of nanomaterials from like electronics or those types of consumer products is really low. It really comes from like improper disposal and waste. So I think if the question is more about like the general public coming into contact with nanomaterials, I personally am the low in concern for those more like consumer products, electronics, things like that. But from like a regulatory standpoint, I would like to see like more obvious labeling and registration of nanomaterials. So for instance, the nanocopper paint that I'm using for one of my studies, has nanocopper in it, but it's not on the label really. So you have to go digging for that information. Like the people applying to this paint probably wouldn't know just by reading the can of paint. And you wouldn't think about it as any other type of copper anti-fouling paint. So just things like that could, people could make that choice for themselves if that label was there. But I am not a regulator, so I don't know where that is in the regulatory process and requirements. But I personally would like to see that moving forward just so that folks could have an informed choice.
Certainly.
I just want to also say that I agree with what Marissa's saying. I think we need to be a little stricter on what is on labels and not, especially when it comes to polymers, is like, what is this polymer actually made of? There has been false advertising, I would like to say, on a lot of products, and I think that's not fair for consumers.
Great, thank you. And we've got just a minute left, and I want to thank the audience. I don't know if the panelists can see it, but we have gotten a lot of questions, and I've barely scraped the surface as far as trying to get to all of these, because we've had, I think, a really great back and forth answering the questions that we already have. And I want to be mindful of everyone's time. I want to thank the three of you so much for participating. I think there is so much great information that you shared as you continue on your journey as NanoEHS researchers, and how you've how you have and how you continue to benefit from infrastructure that has a lot of room to grow, and a lot of a need for broader awareness of that. I want to also thank you for sharing your stories and how you got to where you are and the paths that you took to become NanoEHS researchers. I think that's really valuable for the community to hear. And again, I want to thank everyone who joined us and for all of your great questions that you asked. I was trying to scroll through those while listening to the answers as well. And I want to thank you for your attention and tuning in today. And if you're interested in other webinars in this series, please visit the NNI public webinar page on nano.gov to learn more. I want to remind everyone that this webinar will be archived on our YouTube channel, NanoTube, so you'll be able to go back to it in the future, and all of our other webinars there as well. And to that point about awareness, you can follow the NNI on Twitter at NNI Nano News. You can connect with us on LinkedIn at National Nanotechnology Initiative, and then just keep coming back to nano.gov for more information. And with that, I'm going to end the webinar today. Again, thank you all very much for participating. I really enjoyed it. Oh, I wanted to say we are having our public workshop for EHS strategy refresh on May 31 and June 1. There will be information, of course, sent out to the broader community. So maybe I'll see the three of you there, either virtually or in person, because your perspectives are really valuable, and certainly, as I said, intentionally trying to bring as many different communities together for this as well. So with that, thank you all very much and have a wonderful afternoon.
Thanks.
Thank you.